The broadcast is now starting. All attendees are in listen-only mode.
Hello, my name's Trish Kerrin and I'm the Director of the IQME Safety Centre. Welcome to our webinar today on technical safety planning, case studies of the good and the bad. We're joined today by Laurentiu, Zamfirescu and Steve Fogarty from AMOG Consulting, who'll take us through this process with some practical examples and hints for how you can better get planning in your technical risk assessments. We'll be taking questions at the end of the presentation, so if you have any questions throughout the presentation, please put them in the questions box and I will moderate those questions with our presenters at the end of the session. You can also feel free to use the chat function to contact us at any stage as well. You'll find that on your control panel. So without further ado, I'll now hand over to Laurentiu and Steve to take us through this presentation.
Thank you, Trish. My name is Laurentiu Zamfirescu. This is my colleague Steve Fogarty.
Hello.
And today, as Trish said, we're going to talk about technical safety planning and some case studies of projects we've seen go well and projects that we've seen that did not go that well. So what we're going to cover today at a very high level is the difference between technical safety and occupational health and safety or work health and safety, why we should do technical safety planning, and then the case studies we spoke about, and obviously what we can learn from those case studies so that we all can do better.
Okay, so I guess if we have a bit more of a detailed look at the difference between technical safety and occupational safety, we have a bit of a difference between the various sectors or the various industries that we work with. So in the processing onshore offshore type industry, it's called process safety. For those that work more in defence and rail, possibly aviation as well, it gets referred to more as system safety or technical safety. And then in the mining industry, we talk about fatal risks or material risks as well. So different terminology, but essentially we're talking about the same thing. And what we're talking about here is we're talking about the potential for events to go wrong and for there to be a large impact to personnel. So low frequency, high consequence events. When we look at them as well, the events we're talking about here with the technical safety tend to be more relying on engineering systems or engineering design or engineering controls. It's less related on the individual, but there are still interactions. The other thing to remember as well is that the barriers are different. So the things that we rely on to help protect against these events are generally different. Now, sometimes we share some. So some examples of sharing would be things like permit to work or crane operations. So in the crane operations example, if we were to have a dropped object and it was to hit a person, that would obviously be OH&S safety. But if that was to drop an impact on a processing plant, then that would be more process safety or technical safety. And the other thing to remember as well is that some are completely separate. So things like piping and vessel integrity aren't related to personal safety, but are very much the process safety type areas. One thing to mention as well here is that the diagram here I've gently borrowed from the OH&S body of knowledge was the work that was conducted between the Safety Centre and the Safety Institute of Australia a few years ago. And that's quite a useful resource as well. So you've got information there broken into two sections. One section looks at particularly around process hazards, so the technical side of it. And then the second part looks at the systems and the systems to support managing. So it's a very good resource as well. The thing that's predominantly different when we talk about technical safety is that quite often the barriers don't get routinely tested. And quite often if they are tested or if they are required to activate, unless you actually go looking for it, you won't know. So to give an example of that, if we talk about a trip in a process plant and we have our high pressure trip fail and we end up with a PSV lifting, then we start to see barriers that have been called upon that might have worked or might not have worked. The simple answer there is unless we actually go looking for them, we won't find them. Again, talking about other information that's available to you as a reference, one of the original guidance documents that the Safety Centre worked on was lead metrics. And it broke down for us a lot of those expected barriers, what they look like, and also some of the controls and the KPIs we might look at to help manage those. So in summary of this, I guess it's important that we understand The barriers can be the same, but generally are different. And we are going to focus on different controls because we're talking about, as I mentioned, those low frequency but high consequence events.
So yeah, maybe you ask yourself, why is important to get process safety right or technical safety right? And this is when we're talking about getting technical safety right, we are referring to both during the project design phase and also during operations and all the other life cycle stages in between and even after operations, such as decommissioning. So some of the benefits of getting technical safety right are qualitative, some other can actually be quantified. So we could say that, first of all, technical safety and process safety helps a company be more attractive to employees and communities and governments, insurance and investors. Everybody wants to work with a safe company. So this opens the door to a second benefit, where companies considered welcome by communities and governments can expand and evolve with fewer social and political barriers. Equally important, major accidents can drain out your human and financial resources that would otherwise be focused on growth. So technical safety gives company this ability to determine their own future by avoiding such failures. So we know that any major process safety, technical safety issue results in an obvious direct financial impact. However, those losses can extend beyond on-site and off-site damage and injuries, especially with incidents that cause property and environmental damage. The companies are seen that they suffer adverse financial losses. On the right-hand side, you can see a diagram that has looked at incidents over several continents and how the share price of the companies suffered. So let us also keep in mind that small events, such as those depicted on the right-hand side, still allow the survival of the company, but there are large process safety, technical safety events that are company killers. So some of these are the Bhopal incident, where Union Carbide went out of business, Piper Alpha with Occidental Petroleum suffering the same fate. So nonetheless, let us remember that process safety delivers increased productivity and quality. The systems are better understood and managed, and therefore downtime is reduced. So we spoke that about several life cycle stages and that how you need to manage process safety in all of them. For the rest of the conversation, we're just going to focus on the design phase of the life cycle. So there are many quotes why planning is important and safety planning is not any different. There are, however, okay, we'll do that. Sorry about that. Okay, go back. Okay, so we said there are many quotes on why planning is important, and safety planning is not any different to an overall project planning. There are, however, some very clear benefits and requirements which you get from implementing technical safety into the design project. So first of all, at least in Australia, it is a legal obligation under work health and safety law. We see that a project that has completed the necessary technical safety activities will result at the end in a safer system during operation. So this minimizes that risk. Let's not forget that there are a variety of license and permits required to be obtained, and most of these have some form of technical safety component associated with them. And last but not least, if you identify the technical safety activities required to be conducted correctly and you implement them in sequence and at the correct time, then towards the end of your project, or even in the middle of the project, you will not need to go back and redesign. And this obviously contributes to that project success of you meeting your budgets and timeframes. So we'd like to understand what is your experience. How often do you see project design plans include technical safety components, either if it's a standalone safety in design plan or it's part of the overall project design plan? And for this, Trish is going to help us with a poll.
Yep, so I've launched the poll now. So in your experience, how often does project planning include technical safety components? And we're starting to see some results come in. So once I've seen a few more results come in and we start to stabilise it, I will publish those results for you. So we're certainly seeing answers towards the top end of the range here in general. So quite a few people are saying most times and sometimes, with a few saying always, but we are seeing some rarely as well in that voting process. So what I will do is close off that vote now and share the results with everybody. So that's what we're seeing at the moment for the results. 15% said always, 38% said most times, 31% sometimes, and 15% rarely. So I'll now hand back to your presentation for you. Okay, so you might need to reshare your screen at that point. Perfect.
Cool. Okay, thanks, Trish. So,
Yep, we've got your screen up. Perfect.
cool. Okay, so if we're looking at, I guess, the results of that, what we're seeing is that about half of the time we're including it or doing most of it, and then there is still a very large portion that only has it done sometimes or not done well. And honestly, if we don't incorporate that in the design phase early on, then it's a next to impossible thing to ever catch up on. So, you know, it's not something that you can recover from. It's very hard to incorporate your safety in design on a plant that's up and running, because obviously, you know, those areas that you need to control have already been developed. So some of the results that we see from regulators and from insurance companies with regards to incident investigations show us that a very large portion of errors do come from the design phase, anything from sort of a quarter up to half as the primary cause, and you know, a bit over 3/4 as being a contributing cause. So it really becomes important that if we don't get that design aspect properly executed, then we struggle to ever recover. And obviously the highest chance we've got of getting it done well is to plan for it. So the idea of planning for it and allowing for it is really what we want to try and emphasise. Again, there are some guidance documents that are available. The ISC has a document in particular dealing with process safety application during the concept select phase, so the early phase of design. And what we developed in that document was all around identifying the fact that it's not something that was done really well across industries as well. So it looks like we've got some pretty common findings in regards to the fact that, you know, that process safety aspect needs to be done more consistently and to a higher quality in our projects. So that risk assessment quality as well is pretty critical. I guess making sure we have the right subject matter experts involved, and that includes our ops and maintenance people, both well documented and done early on, gives us a pretty high chance of success. And in my personal experience on various projects, even with the most difficult PMs, if you have your risk assessments all done early, well documented, the chances of them changing things is fairly minimal. The reason being that you've already got an agreed position, and the changes in design that occur late are generally more expensive and more impactful. So getting them in early is really important. Now, when we talk about these design flaws that might be presented or not presented in the project, they can be, I guess, latent ones that we know nothing about, or they can be intentional ones, that is, ones that we've accepted. And when we talk about the accepted ones, there's really sort of two main groups. There's the, I've accepted them because I think that risk is okay, and there's the accepted them because I didn't really understand the risk and I didn't explore it properly. So an example of that would be if we look at the Nimrod case study, so the one where we had the incident with the aircraft fire while it was doing some refueling. And what happened there is that there was modifications made to the airframe where fuel lines were now allowed to run into compartments that were not designed to have fuel. And it was deemed that, that was an intentional change. It was deemed that it was not required, but obviously that wasn't the case. And then we can have other ones where we make changes and we actually miss the hazard or the consequence. So Piper Alpha being a point in case, when we looked there and we changed over some of the module locations and there was condensate put in close proximity to the accommodation modules, what we had then is we had a risk of a vapor cloud explosion. And previously all the protection for that system had been designed with firewalls, so not rated for blast. As soon as you introduce a vapor cloud and you have a blast, it doesn't matter whether your firewall's rated for 10 minutes or 12 hours, it's not going to survive if it can't hang on to the supports it's been anchored to. So that becomes really critical that we both plan for it, but also that we do those risk assessments properly with the right people.
Thanks, Steve. So we spoke about regulatory approvals. That is just a list of some of the commonly found regulatory approvals in Australia, and this is for different projects. Some of those are more well-known, some of them are less well-known. It is also that there are numerous regulators going from the fire authority to the building compliance inspector to the EPA, Department of Mines and Petroleum, that handles dangerous goods, energy safety, that looks at gas appliances, etc. So identifying what are your legal obligations and those regulatory approvals, and also if you have any license conditions very early on, and making them design requirements or design deliverables will lead you to the success of them actually getting implemented throughout the design process. So we have another poll question here. If you would want to share it, Trish, please.
Yep. Okay, so here we go. The poll is now launched. So in your experience, how appropriate and well executed are technical safety aspects of the project plan? So you can go and put your votes in now. And I'm starting to see the results come in, so I'll just give it a couple more minutes to get a few more of the last votes in.
Yeah. The first question was to understand whether we actually identify them and include these requirements in the project plan, and then this other second question is, well, we've identified them, are we actually doing what we're supposed to be doing?
Yeah. All right, the voting seems to have stabilised out, so I'll close that poll and share the responses now with you. So what we're looking at is some interesting results here, I think, from the experiences that you're both talking about. So 18% said good and 82% said, well, we're meeting requirements. So you can now go back to sharing your presentation to continue discussing the poll results and your slides.
Yeah, you need to close yours, Trish, first. Yeah. Go.
Yeah, that's good.
So you can see that screen again, Trish?
Yes.
Cool. Okay, so what that's sort of telling us is that once we actually do the planning and incorporate it, it actually is a pretty good result, which is showing that generally we meet the requirement. We do what we need to do, and things will end up getting captured in court, which is a good thing to see. So our experience generally is that we see the planning aspect of the safety side seldom done. So similar, I guess, to what the poll was saying. But when we look at getting it done well, quite often there's parts of it that are missed and stuff that's carried through. So it's interesting that the group had a slightly more positive experience with it. But maybe if I get people to have a consideration of some of the aspects that we see as suffering, then maybe that might require some people to have a bit more of a reflection on, you know, was it meeting requirements, or were we just accepting of it in the end because, you know, the project kept moving forward and we still had to deliver the project. So quite often what we see is unclear requirements. So the specification of what we actually need to achieve is not that well defined. Cost and schedule overruns are quite often caused by rework or redesign or changes or things that aren't incorporated properly. That can obviously also lead to project delays. A little bit less often, but a little bit more troublesome is when we hit government approvals problems. So there we might get approvals for early works, but when we get to the detailed design and we have problems, then they can tend to be a lot more impactful. So less common, but quite impactful if they occur. And then in the last sort of stages of things, we can also see things go wrong in the operation stage. And in that case, what we end up with is notices or improvements from regulators. And that obviously has occurred in Australia, even on some of our big super projects with, you know, facilities that we haven't built before that we've installed, and we think they're okay, but when they're up and running, we find that we have problems with them which we don't understand, and it requires regulators to step in and stop the facility until it can be proven that it's safe. I guess the important aspect to bring out here is that the earlier the work is done, the bigger impact we have on risk reduction. So the longer we leave it and the more stuff that's undefined or not worked out, the harder it becomes. And in our experience as well, the more collective delivery of the actual studies, then the better chance of success. So if the safety study is carved out to be, you know, HAZOP, HAZID, LOPAs required by this particular group, you know, instrument and control, you can look after functional safety, then the likelihood of success is a lot lower. If those responsibilities are understood and shared between the wider groups, then there's a better chance of getting a quality product at the end. The other thing to remember is that generally if there's a hazard or something that's been identified that hasn't been properly addressed or isn't in the current design, it's not as simple as magic wanding it and getting it sorted out straight away. Generally it will take some time and some iteration to get those risks understood properly and a suitable design to occur. So again, the earlier those are done, the better chance you've got for people to allow some headspace to solve those and consult all the groups they need to come up with a good design. If you don't do that, for anyone that's worked in large projects, we know what happens. The beast will continue to run. Those assumptions will carry through. On the good projects, they'll go back and they'll check them and make sure it's okay. On some projects, they just get snowplowed and they keep going ahead. But making sure that they're actually clearly understood and documented is critical to the project success in the end.
Okay, so we get into some of the projects examples and the case studies that we are presenting. This one is about a power generation facility which had a flue gas scrubbing system associated with it. It used powdered activated carbon, which can be a combustible dust and represent an explosion hazard. We were lucky that hazard was done early in the project, so this hazard was picked up. However, the project team, and there was a recommendation to conduct further assessments and understand the level of impact, or simply to place it outside of the building, so we wouldn't have that confinement and elevated risk. Unfortunately, this recommendation, none of them was addressed during the design process. So what we got to have is the actual activated carbon tanks placed inside the building, as well with the associated conveyance system. The building was obviously not designed to withstand the potential explosion or to provide explosion relief. So the end outcome was that the project carries significant residual risk, and this one is both with the regulator picking up that the assessments that were required to be done in accordance with our standards and good industry practice has not been done, and then also with the end customer. There were several other issues on the project which saw the schedule the schedule not go well, and then the cost overrun also to go back and change some of these requirements. And as it happened on this one, they were changing the design after construction had commenced. So you can imagine what the cost impact of such an operation is. Right. Another example was for a pilot plant. This one is the pilot plant handled flammable gas and combustible dust. In this situation, the outcome is a bit better, that we haven't done. The client hasn't done any safety planning for the project in the beginning, but it was done a bit later on. So in that way, we were able to save the project. Some of those inherent safety measures that we implemented to manage these hazards was obviously on open structure, where initially the client was considering of putting this inside a building. This obviously prevents a lot of that explosion risk. There was no need to put expensive electrical cabinets in hazardous areas, and because we picked it up, we could arrange the layout so that they are outside. And then if we're talking about safety instrumented functions, we were able to put very simple hardwired systems, and we didn't need to bother with PLCs and programming and such. So there was, because all of these activities were picked up late, there was a certain project overrun and schedule impact, but in this case it was a lucky example, and they were able to correct it prior to construction.
Thanks, Laurentiu. Okay, so the next one we're looking at here is a minerals processing facility, and this was essentially some work that we did with a client in pre-feed. So we're looking at a reasonably complex minerals processing facility. We're talking about solvent extraction, we're talking about ammonia storage, we're talking about autoclaves. So we're talking about flammable hazards, we're talking about high temperatures, we're talking about toxics. So it was a pretty I won't say it was high risk, but there were high latent hazards there that we needed to address. So the good aspect of this one is the risk assessments were conducted nice and early with the relevant people. So that included both technical experts and also the early operations crew. We also had some good engagement with the approval authorities very early on. So this was in an area that wasn't traditionally used to having MHFs and mineral processing facilities in the region. So making sure that was understood quite early on was good. There was also some significant improvements we were able to make. So the firefighting system that was proposed through the solvent plant was essentially a common system across the entire plant area. So what that meant was that if there was a particular incident that was to occur in one area, it was going to require the entire catchment area to be essentially blanketed and filled, which led to the possibility of, further escalation if the system was to not function as intended. So we were able to do some compartmentalisation and some different systems to minimise impacts and volumes and inventories and all sorts of things in that respect. There was also a desire to understand what the functional safety requirements were very early on. So rather than leave that for detailed design, we did some early feed functional safety studies to allow us to understand the level that was required. And the other thing that was really good is we had a clear involvement of all the various disciplines into the schedule and into the team deliverables. So it wasn't technical safety's responsibility or instrument control's responsibility. It was sort of shared responsibilities, and everyone understood which studies needed to be done in what sequence. So no, that was quite a successful one for us.
All right, we moved from a quite successful one to quite a dramatic one, to say so. So this was a dangerous goods storage facility in Western Australia. There is this requirement to hold a dangerous goods site license, and for that site license, essentially you need to demonstrate to the regulator that you've identified the hazards, you're managing the risk, and also that the facility conforms to Australian standards. In this case, it was very clear-cut what the standard was requiring. There wasn't really anything special about this place. The only problem was that they identified very late in the project that they need a dangerous goods site license. And when I'm talking very late is when the building was completed 90%. Now, the problem in this specific case was that you couldn't add on and bolt on the required safety systems to the building. They had to be an integrated part of the building. So they called us in to help them with a conformance assessment, and unfortunately we told them that they have major flaws and that they actually cannot obtain a license. So now where both the contractor and the end client are is that the DNC contractor has the obligation to deliver the project, and they have no budget. The client doesn't have a conforming design, so you can't go forward to construction. So it's essentially a very lose-lose situation. Nobody benefits from this one, and somebody somehow will need to cope the financial loss.
Okay, another more positive example. So we're doing a bit of a sandwich here with good and bad. This one in particular was looking at a mining site within Western Australia. And what we were looking at here was an expansion program for a site, and we were looking at trying to consider various options and various design scenarios to both achieve the production forecast, but also to manage the risk. So it was all around trying to understand the risks with the various options, and also, I guess, try and preserve some production targets if possible. So the transport risk that we looked at was around the different configurations with autonomous, with driven road trains. We were looking at the risk associated with both the haulage, but also with the personnel travelling on the roads for other reasons between camps and sites. And we were also considering both public roads and private roads. So what we're able to do there is do essentially a semi-quantitative risk assessment across the various options and be able to present the risk of those options. What we did identify very early on was that there was, as part of the base case or the assumed case, a very, we'll call it suboptimal option. So there was a case that was going to both increase risk and cost, but it was perceived that there was nowhere near the risk increase that we were able to demonstrate there was when we actually put some numbers behind the science. So that allowed the project to reassess based on it being done nice and early and redefine what the base case was, and then, I guess, achieve the cost savings, but also the risk reduction. And I guess lastly, what we're able to do is essentially assess that risk to make sure that it was acceptable to the business, but also to be able to provide some short-term options for some production between the start of the design and the final long-term design. So that was, you know, a good example of planning early, doing the right studies and having time to adjust and modify your design appropriately.
Cool. So this is an example which you will be able to see all of those things, pretty much all of those things that you shouldn't do. They have been done, and then it was the disastrous outcome of the project. So some of those things were identify your design requirements in terms of standards, engage early with your approval authorities, have a safety plan drawn up, and so forth. So the project started in February 2016. It's a facility handling various commodities, including hydrocarbons in bulk. The facility has been around for many years, and there was a project in place to upgrade the firefighting system. So in that February 2016, the client engaged the services of a fire safety engineer. So for those even inside Australia and outside of Australia, fire safety engineers focus on building fire safety under the National Construction Code, as we have the requirements here, and they have very limited experience with industrial hazards such as hydrocarbons or dangerous goods. There is a requirement to assess those and look at them, but it's only a requirement. So the consultant developed a firefighting strategy report 1 year later, and then the client started raising capital for the project. Before they actually went ahead to start construction and then tender out the construction contract, they called us in to conduct a third-party review of that strategy before they commenced the detailed design. So what we found is, as a fire safety engineer, they have used the building fire system methodology requirement. The hazard identification was not adequate. They did not consult with the local fire brigade, which needs to have a say in these systems. And there was actually no reference to any standards for handling hydrocarbons. So in this situation, the problem was from a risk management perspective, regardless of what was done, what was not done, was that pool fire was a major concern at the facility. So this was one of those items not identified. So there was no bond in place. The project did not specify one to be implemented, nor identified a problem from running pool fires and the impact these can have. What the project did propose, they proposed to use these mobile foam trailers similar to these ones, which whenever they would engage in hydrocarbon transfers, they would roll in these trailers to be on the standby in case they need to intervene. All good and nice, but then there are some problems to this one, because the fire scenarios were not clearly defined, where we'd have a running pool fire and it can affect the vicinity, and then also it's a huge difference between fire load in a building, which we'd see, carpets and curtains and timber burn, and the hydrocarbon fire. So from this perspective, the monitors could not reach the fire, because the personnel manning those monitors would be exposed to a very high thermal radiation. So we said the client engaged us before the detailed design was started, to conduct a third-party review. Somehow they started and they awarded the detailed design before we finished our review. And then even after we provided the review to the design contractor, they just continued based on the previous firefighting strategy that was developed and missing. So they got to the point of 75% of design complete, and about 24 months after this whole thing started, and they go, we're not managing pool fire, we don't have a bond, we have so many original assumptions that that are inadequate. Well, they thought, well, as a solution, we will use the fire brigade to do our response. No more mobile fire trailers, and we're just gonna push on and design the system based on this new philosophy. However, again, as it happened, the fire authority, which also not only that it needs to approve the design, but then they also need to respond to an incident, they were not consulted. So we're 48 months down in the project, and we actually don't really have a design. So this kept on ongoing with understanding this and relay and interacting with the firefighting brigade. The firefighting brigade actually got to write to them and say, your design is not conforming, you have a bad philosophy, we may not show up to put out the fire on your facility. So this is lots of time afterwards, and as you can imagine, the cost associated with this entire endeavor was quite significant. So this would be one of the worst examples we've seen, and I'll pass it on to Steve just to talk on how we can do better so such things don't happen to our projects.
Thanks, Laurentiu. Yeah, I think for me that one is a good example of that project machine starting and the wheels turning and just keep going ahead regardless of if the assumptions are good or if they've got reports that tell them something's wrong. Because quite often, you know, once it gets up and running, it's very hard to change the inertia and to redirect it or to make it stop and reassess. So just to re-emphasize again, I guess what we're saying when we talk about planning is we're talking about making sure we understand what deliverables we need. Now, that doesn't have to be complicated, depending on the level of risk you're exposed to and the facility you're working on. That will probably drive how complex it needs to be, but you should always try and keep it simple. But it is important that you understand the flow-on consequence between the various studies. So you can see there we've mapped out one that we did for one of the clients. And the important part here as well, though, once we actually start to put that into a schedule, is having the hazard finish, and the next week we start off doing bow ties is not something that works either. So we have to make sure that we allow sufficient time for the studies to occur, for the recommendations to surface, and then for the solutions to be developed at the same time. Quite often as well, particularly with some of the designs we get involved in later, we find that the requirement for Australianisation or the use of the relevant standards that we expected to use hasn't been incorporated. So as a starting point, understanding what standards apply to you, and then whether you will use them or not, or if you don't use them, why not, is a very good position to be in. There's a project I'm currently on that's dealing with some underground mining, where there are some standards that exist that aren't necessarily applicable to the type of work that we're undertaking. So there's some discussions with both client and regulator to gain approval to the fact that we won't be using those standards, but what the hazards are and what the controls will be. So they're not a given that you have to use, but they are definitely the right point to start at. And then I guess, sorry, lastly, I guess making sure that you allow those hazard studies to occur sufficiently early. We can have all this plan mapped out, but if we don't start all this until detailed design started, then what we might find if we find something is we can't afford to stop everything else. So the earlier you can conduct these studies in sort of concept, select or feed, the less impact you'll have on the detailed design later on. That's basically the best time to do them. The last aspect I want to address, I guess, is the in-house versus contracted. So this is looking at, you know, what is the best way to manage both the planning and the assurance aspect for technical safety. And if we sort of look at the analogy of HAZOPs, HAZOPs, I guess, have been done for a long time. They've been proven as a very effective tool for managing hazards, and they're run by independent facilitators for a reason. The premise there, I guess, is that you provide someone who's not directly involved in the project, who doesn't have either skin in the game or they don't have, previously made decisions, so they can come in with that clean set of eyes. And it's also similar to what we see in the functional safety standards, where they provide, I guess, an objective judgment call into the process. So if you don't have independence available within your organisation or available to the project, then it's, it's best to look at getting that done by someone else in that particular expertise with the independence. And then I guess what you're trying to make sure that occurs then is you've got both the quality that's required to be done is executed, and also that you don't have activities missed or assumptions made and then not reassessed or not considered in the end. I guess too often what we hear from some clients is, it's too complicated, or that's not the way we do it, or, we do it this way. And the problem there is quite often that things that need to be considered, if they're not exactly the same and it's not a cookie cutter from the previous job, there will be things that will be missed that that should have been picked up earlier on. And if they had been picked up, there would have been no issue. It would have been a relatively simple change. And you would have had, a design that incorporated and managed the risks, as opposed to one that has a risk that's sitting there that might eventuate later in the operational phase.
So these are the references for those incident statistics leading back to design error. And with this, our presentation is concluded, and we'll give it over to Trish for comments or questions from the audience.
Great, thanks, Steve and Laurentiu. That was a really interesting presentation. If you've got any questions that you'd like to ask either of the presenters, please type them into the questions box or the chat box, and I will ask them. One question I wanted to just draw your attention, or area I wanted to draw your attention back to, and it was when you were talking about, some of the examples of the proving it safe versus proving it was unsafe, and you started to talk about a couple of incidents. Nimrod was one of them, Piper Alpha was the other. And Steve, you actually reflected on them about the changes that had occurred and what impact the changes had, and how the risk assessment hadn't been done adequately to understand it. I guess, is there any other advice you can offer around how we can better management of change? Because essentially that was the failure that occurred in that instance, both of those instances, managing the change.
Yeah, that's correct, Trish. I guess the interesting part there, though, is that you could argue that the change was managed as a project. In both cases, they were talking about upgrades or modifications to the facility, which were actually, delivering a project onto a brownfield facility. And quite often the risk that happens there is when it's not a greenfield facility and there's existing information, it's not necessarily well understood, well documented, nor is it challenged. And quite often, the rigor that we would go through for a greenfield facility is just assumed that, the basis of the design is done, that philosophy's been done, let's reuse that. But taking that time to actually reconsider what the true risks are and what you need to manage is quite often missed. And we know about the letters in assumption and what they mean. So going back and doing that properly is really critical.
Yeah. So my experience with this one, and it was primarily when working as a regulator for major hazard facilities, was, and I've done numerous audits on management of change processes, and the processes themselves were primarily okay. Where they were failing was to identify actually these bigger projects and put them through the MOC process. They would do the MOC process if they were to send to change a set point, a material of construction or something, but these bigger projects were not put through the management of change process, and then they were again not put through this safety planning process where they would identify what safety activities they need to conduct. So you could say that managing small changes was better done than managing bigger changes.
Yeah, interesting. Thank you for that. We've got another question here. So how do you train up new project managers or engineers in process safety on projects? Do you have any advice or tips in this area?
Okay, so that was both project managers and who was the second one, Trish?
Project engineers.
Oh, okay, completely different strategies. I guess project managers are the decision makers. They're the ones that need to understand how to deliver the project. So for them, it's a little bit more around the project delivery and understanding the different studies and the interactions. So they need to understand how it impacts on the delivery of the project, and also on the importance of completing the studies early on, so you can lock in some of those design aspects and not have them either floating as something that's not been locked in or something that needs to be changed later. For the project engineers, it's more their technical involvement in the area that they're involved in. So although you might have a mechanical engineer that's not directly in the, the process safety team, or in the, in the team that's looking at the instrumentation and the control, they are going to have some critical aspects in the mechanical aspects, in the mechanical engineering, with regards to things like material selections or design codes for cyclones, or, whatever their particular inputs are. So for the project engineer, it's more understanding where they fit into that overall delivery. For the project manager, it's about understanding the critical parts to the delivery and making sure that the timing's done appropriately. So that's, I guess, what they need to know. The best way to get that to them really is going to depend on the organisation, the time you've got and the resources you've got available. There are, I guess, different resources available in the written space. So I mentioned before, Body of Knowledge is a really good reference for understanding hazards and systems to manage. Mm-hmm. But then there is also tools for higher management type decision makers as well. So I know IQME also runs a course related to process safety up to the board level. So I think there's going to be no sort of perfect answer for that. It's going to be a little bit of some, I guess, courses, but it's also going to be some coaching and some mentoring from some other people who might have the right experience that can help them out. It's very rarely that you're going to be able to go to a course for 4 or 5 days or 2 or 3 days and come back and have all that stuff sorted out. It's more information, time, a bit of practice and a bit of coaching.
Yeah, and that what I'd like to add is who's doing the assurance. Is like if it's an internal project manager to the company, is the technical authority doing the assurance, or you need to get somebody in. If it's an external party, a design contractor and such, does the owner have engineers qualified that can do that assurance and make sure that they are actually doing what they're supposed to do? So this is just on top of what Steve was saying.
Okay, thank you very much both for that. As Steve mentioned, there's actually a lot of different guidance documents that Steve talked about. So what I'm going to do is actually just bring up my screen very quickly for you all to actually show you the IQME Safety Centre website. So the URL is up the top of the screen, so you can take a look at that website at some point and have a look in our publications area just here in the middle menu there. There's a whole range of different publications available for you to be able to download and use. Steve and Laurentiu did mention quite a few of them today. So with that, what I will do is actually wrap up this webinar and thank our presenters, Steve Fogarty and Laurentiu Zamfirescu, for taking us through what they've discovered and their experiences in the good and the bad of technical safety training. The recording of this website will be made available on our YouTube channel over the next couple of days. So if you want to share this with anybody else, feel free to access it and check out that detail. We'll have more webinars coming up for you shortly over the next few months. We're still scheduling various different ones in. And for the Safety Centre member company representatives out there on the line, also remember we do have our member conference coming up next week if you're available to log into that one for 2 hours on both Wednesday and Thursday next week. Just to finally close off, today is actually World Day for Safety at Work, so a really appropriate day to be talking about process safety and how to get it right, and an important day to think about those that have tragically lost their lives in workplace incidents and what we can do better to prevent that happening in the future. So I'd like to leave you with that thought of what can we do better in process safety so that people do get to go home safe at the end of their day. Thank you very much, everybody, and stay safe.
Thank you for having us, Trish.
Thanks, Trish.